The next topic we'll discuss is tagged template literals. We have already discussed what template literals are. Here we have an example of a template literal. We have a string here whose value is hello world and it's enclosed in backtick symbols. So this is a template literal. Now let's look at an example of a tagged template literal. Let's read this line of code. Const s equals, we have f followed by the template literal. In this line of code, what we have done is we have tagged this template literal with f. And what is f over here? F will have to be a function, and in our case, f is a function that takes in one parameter and it's converting it into uppercase. So f over here is the function f over here, and hello world is passed as an argument to the function f. Let's look at some examples and discuss a little bit more. Let's examine this code. We have const str1 equals good. This is a string. And then we have a tagged template literal. We are calling f with this template literal. And f is defined over here. What happens when this line of code gets executed is JavaScript will pass this string to f by splitting it into several pieces. Let us look at those different pieces. The first argument will be an array, and the elements of the array will be the string that has been split at the positions of interpolation. For example, we have one interpolation being done here for str1. So this string will be split at this particular point. So this will become the first element of the array, and this will become the second element of the array. So that is the first argument, which will be an array, and then the rest of the arguments will be the interpolation values. Here we have only one interpolation value, str1. So other than the first argument, which is an array, there will be one more argument, str1. In this function f, let us write to the console both these arguments. Let me run the example. I'm clicking on run, and let's see what we get in the console. As you can see in the console, we have the first output as an array, and it has two elements. Today is the first string, and space day and dot as the second string. As we discussed earlier, these are the pieces of the string when we split the string at the position of interpolation. Today is and space is the first element in the array, and space day dot is the second element in the array, as you can see over here. And the second argument, value 1, is good over here, and that is because the rest of the arguments that are passed to f are the interpolation values. Here we have only one interpolation value, so we have been passed only that interpolation value over here. It is worth noting that this particular function call is equivalent to this. Let's look at one more example. This example is similar to the previous example, but in this example we have one more interpolation value. So we have two values being interpolated. str1 and str2 are going to be interpolated into this string here, and we have tagged this with f. So when f gets called, the array of strings come into strings arr, and these interpolation values of str1 and str2 reach value 1 and value 2 respectively. And within f, we are writing strings arr to the console, and the values value 1 and value 2 to the console also. Let's run this and look at the output. As expected, the first argument is an array, which is the result of splitting this string at the positions of interpolation. The positions of interpolation here are this over here and this over here. So we have an array containing pieces of this string. Let's suppose we want to add a third string to be interpolated. Let's say we have a const str3 equals even better, and we want to change the string to say tomorrow will be, and we want to pass in str3 over here. Since we now have a third interpolation value, str3, we need to change the function definition to accept a value 3 as well, and let's log value 3 also. Let me run this example and see if it works. As you can see, the example works. Since the number of arguments that come after the first argument are going to be variable, we can use the rest syntax instead of these. So let me replace these value 1, value 2, value 3 with the rest syntax. I will say values ARR, and let me replace this with values ARR. What this will do is the rest of the arguments will be captured by values ARR, and values ARR will be an array. Let me run this example and see if it works. As you can see, the example still works. Now if we decide to remove str3 and remove this, we do not need to modify our function definition. Let's clear the previous output and run it once again to see if it works. You can see that the example still works even though we haven't changed anything in the function definition now. The important point to remember is that when we are using tagged template literals, we are passing the string within the template literal to f, but that string is split up in a certain way based on the positions of the interpolations, and the interpolated values are also passed as rest of the arguments. Within this function f, we can then decide what to do with those strings and those interpolated values. We can decide to construct a new string using these values. We can decide to ignore them altogether. It is basically up to us what we want to do with those values. Again, the main point to remember is that when we use tagged template literals, we are essentially doing function calls. With respect to how often we use tagged template literals in React applications, usually we do not need them for most of our requirements, but when we are using style components, the style components library uses the tag template literal syntax heavily.